Hi, in this video we're going to be looking at inequalities in triangles. But before we really dive in, I want to talk to you about a couple kind of quick vocab things. There's this idea of a chain of inequalities, and the idea is we kind of got these series of like, you could do it with series of less thans. I think this makes more sense. Or you could do it with a series of greater thans. It's like 8 is less than 20, which is less than 35, or 45 is bigger than 18, which is bigger than 17. So they kind of keep getting smaller or they keep getting bigger. This is kind of my preferred way to write them. I think it makes the most sense. Then we've got opposite. Angle A is opposite side BC. So like if we've got this angle right here, so this angle goes to this side on the opposite side of our triangle. And then that's true about C. C goes over to this one, B goes over to this one. So we've got this opposite side from this angle. We don't want A to be matched with the side that it's touching because we don't know which one that is, but A is only opposite one side of our triangle. So this side BC, B is opposite CA, not CD, and then AB is opposite angle C. Okay, enough of that. Here's the big thing. Based on these two theorems, we get this idea. If you've got a big side, you get a big angle. If you've got a medium side, that's a medium angle, and a smallest side, you get a smallest angle. Now, the two theorems are just about larger side, uh, longer side, and so let's try that out. So we want to list the angles of the triangle in order from smallest to least. Uh, So we've got 8, 6, and 13. So this is our smallest side. This is asking about our angles. So we need to go to the opposite side of the thing. So that is telling us that angle B has got to be our smallest angle. So the measure of angle B has got to be smaller. So that's a less than. This is an angle measure. The measure of our next biggest side, our medium side is 8. So then we get the measure of angle U. Then we make a nice big inequality for U. And then finally, 13 is our biggest angle. And you can tell that this is the only obtuse angle. So that better be the biggest. So that is the measure of angle L. Now, be careful about this that you make a distinction between where these angle things are and these less thans because they're easily confused. So you've got the measure of our angle and then you've got that less than. So I would make these ones kind of big and then these guys really little just to kind of help you see the difference. Our next theorem says that if you take two sides of a triangle, it's got to be bigger than the other two sides. So what that kind of means is the quick way to get from B to C is to go straight across. If you have to kind of go up to A and then down to C, this is going to take longer going along this way than it would be to go this way, which is much shorter. Is the idea of this theorem, and that's true about any of the side lengths. So we want to decide if a triangle can have the given lengths, and we're going to explain why by showing calculations. We have to take all these pairs, add them up, and make sure that they're bigger than the other side. So maybe we start with checking, is 12 plus 15 bigger than 17? Well, that's 27, which is bigger than 17, so yes, that one works. Now we try the next pair, 12 and 17 maybe. So 12 plus 17, is that bigger than 50? Well, that is 29, which is greater than 15. Yep, that works. If I had gotten like 9 over here, that wouldn't have worked. And then I wouldn't have been able to have a triangle. Our last one, let's see, we've done 12 and 15, 12 and 17. We haven't done 15 and 7. 15 plus 7, is that bigger than 12? Well, that's 32. That's really big. So, yes, we are able to make a triangle because all three of these worked. If any of these hadn't worked, we would not have gotten a triangle. So make sure you check them one by one. And I am going to be looking to see all of these. If you just wrote, yes, we can make a triangle, that's not enough. You have to explain why by showing calculations. And that's what we did with these three things. So make sure you do that. Now, in this example, I've got two sides, but I don't know what that third side is. So I've kind of got this third side X, and I want to make sure that everything is going to work out okay. So again, I'm going to do those three inequalities. I want to make sure that 6 plus 17 has to be greater than whatever X happens to be. So that's 23. So I know X has to be less than 23. If I reversed the inequality, X has got to be less than 23. I think it makes a little bit more sense to talk about it that way. Let's try another pair. We could have 6 plus X, that's got to be bigger than 17. So if we solve that for X, subtracting a 6 from both sides, that's telling us that X has to be bigger than 11. So we got to be less than 23, bigger than 11. So the last one is we could have 17 plus X has to be bigger than 6. So that means I got to subtract 17 from both sides. So X has got to be bigger than, let's see, that's negative 11. So that doesn't really tell me anything new. I knew X has to be bigger than 11. Uh, if it's bigger than 11, it's got to be bigger than this negative 11. So this is kind of pointless. But I did want to do all three in case it did give me something helpful. And usually you will get one that's pointless. So we want to make sure that X is less than 23, and we got to make sure that X is greater than greater than 11. So to do that, I put X in the middle first. So this should be in the middle every time. And then I want to put these two inequalities next to it. So I want to do the smallest thing last. So X is less than 23, so that's bigger. X is bigger than 11, so 11 is my smallest thing. So I'm going to put 11 first. That's going to be less than X. So X is greater than 11, 11 is less than X. And then we've also got this piece over here. X has to be less than 23. If we wrote that in the opposite order, you would be okay, but I would always keep X in the middle. So we could have also said 23 is bigger than X, which is bigger than 11. That would also be fine, but I like doing that top one first. That's it for our video. So a reminder of our two theorems. It is shorter to go directly than it is to go around. And this table right here, if we got a big side, we got a big angle. We got a small side, we got a small angle. Medium-sized angle. Thanks for watching. Make sure you made those corrections, and bye-bye.